Well, hello again and welcome to the VK6S Fun with Amateur Radio channel. Now this meter here is 1 milliamp full scale deflection, and this is the grid current meter out of the GS35B linear amp, and you've probably seen me I would show what the meter is indicating, which is normally about half scale, and say, well, I haven't calibrated this meter, but I think that's about 250 milliamps. So I thought, just for fun, I would take the meter out and calibrate it. So there we go, I've duplicated the shunt. I've got it in series with this meter here, and I've got this power supply connected to it here. And because there's a little bit of voltage coming out of the power supply, there's a bit of residual current there. It's about 30 milliamps. Okay, so that's indicating 30 milliamps there. So if I just turn this gently up, so I don't want to pop my meter. Okay, so if I say, well, that's about where it normally goes when the amplifier is running. It's normally pretty much vertical like that. So, you know, that's 250 milliamps. So that was about right. That was about right. I said it's probably about 250 milliamps of grid current, but now I know that that particular mark on the scale, the mark before the 0.6, is 250 milliamps. And if I turn the, if I continue turning the power supply up, I'll just check the full scale deflection there, and surprisingly, it's not 500 milliamps. It's 460 milliamps. Full scale deflection. Okay. So if I turn that back then to, oops, that point there, that's 250 milliamps, and I'll just turn it up to until the digital meter indicates 350 milliamps. It's not as easy as it seems. Okay, there we go, that's 350 milliamps, and that is one mark before the 0.8. So 250 milliamps is one mark before the 0.6, and 350 milliamps is one mark before the 0.8. So it's just a little bit non-linear at the top of the scale there. Yeah, it was 450, was it? 450 or 460 full scale. But okay, so that I know that between the one mark before the 0.6 and the one mark before the 0.8 is the region it wants to operate in. I mean, 350 milliamps is probably a little bit high, so what's 300? Where's 300? Just adjusting the. There we go. So that's 300 milliamps there. So that's you know, just past the 0.6. So you've got one peg and a bit past the 0.6 is 300 milliamps. I think that's all I need to know, really. I don't know whether I'll actually change the scale of the meter, but yeah. So that, where it often sits, is 250 milliamps. Almost vertical, and that's a very healthy grid current for this particular, for the GS35. And that is, whoops, that's 350 there. That's 400. The valve would be very unhappy, I would think, with 400 milliamps of grid current. I haven't checked the spec, but yeah, and 460 milliamps, or 450 milliamps, sorry. Not quite full scale. Yeah, so it's 460. full scale deflection with that shunt. I don't think I'll bother changing that. I don't think I'll bother changing that to you know, to be 500 full scale. I mean, I know where the 250 is, and the 250 is pretty much vertical, straight in the middle. You know, I know where the 300 is. I know where the 350 is. So there we are. Now I know what that meter is actually indicating. Rather than it being just a relative grid current indicator, I now have some numbers that make that meaningful. Okay, well, I hope you found that interesting. As always, many thanks for watching. I'll catch you next time.